Hi everyone, now let's look at the final examination questions for question number 3b. Okay, so this is the final examinations for semester 1, 2022 and 2023. Okay, so question B, you have to evaluate. Okay, evaluate the double integral z dx. Okay, where sigma is a portion of the 3D graph. Okay, so this is the equation of the 3D graph with the z greater than 0. Okay, by following the step below. Okay, when you look at this graph, okay, the equation of this 3D graph, okay, you can easily identify that this is actually a sphere. All right, so you have to do the following steps: draw the 3D graph, okay, show the steps, okay, project the 3D graph on the xy plane, and solve for the surface integral of the equation given in the questions above. Right, okay, so let's start it. So this is question 3b. Okay, so we write down the important informations, okay, which is the equations of the 3D graph. Okay, the equation of the 3D graph is x squared plus y squared plus z squared equals to the 4. And here that mention is the z is greater than 0. Okay, so it refers to the actually the upper hemisphere. Okay, so you can start plotting the hemisphere. Okay, so you can write down first the radius is equals to 2. 2. Okay, so let's draw it. This is upper hemisphere. And you use this line. Okay, something like this. So you label it, and the most important thing is you must label some points in the 3D graph, okay, to tell us that you know what is the radius of this 3D graph. Okay, so this is the question number 1. Okay, so you have sketched it. Okay, question number 2, okay, is the projections. Okay, so projections means you have to view these structures, okay, from different directions. Okay, you can pick the xy projections. Okay, so when it is xy projections, you will be able to view these circles over here. Okay, so you can transform this circle into the 3D graph. No, it's a 2D graph. Okay, right, so 2D graph. All right, and then a circle. Okay, so label the point 2, 2. Okay, so this one will be the xy projections. Okay, so besides drawing the xy projection, you have to define the interval. Okay, the interval. Okay, so you can say that you want to use the polar coordinate. So for the polar coordinate, you will have dr and also d theta. So dr will be from 0 to 2. Okay, d theta will be from 0 to 2 pi. Okay, you might be confused. What is the interval mean in these questions? But if you look at the question number 3, they actually want you to find the surface area. Okay, so surface area, okay, maybe I'll write down here. The equation for the surface area is equals to integrate, okay, so the fx squared plus the fy squared plus 1. Okay, so this one is when if you choose the xy projections, behind it will be dA. Okay, so they ask you to define the interval because they need you to know this interval interval for this surface area integrations. Okay, so this why they ask you to find the interval. Okay, so for these questions, they give you this one actually, the double integral z dx. Okay, so they are asking you to find the surface integral of this. Okay, meaning that you must include the z. Okay, you must include the z over here. Okay, the z must be included over here. Okay, in your calculations. Okay, right. So we go to the term inside. Okay, which is this one and also this one. You need to perform the differentiations. So what is your f? Okay, so the f is your 3D graph, which is a sphere. So you have your z, okay, equals to 4 minus x squared minus y squared and square root. Right, and square root. Okay, so this is your hemisphere, upper hemisphere. So the fx will be equals to 1 over 2 4 minus x squared minus y squared minus 1 over 2 minus 2x. Okay, you can simplify it as negative x over, okay, 4 minus x squared minus y squared and square root. Right, so for the fy, okay, similar procedure, you could write it as negative y 4 minus x squared minus y squared and then square root. Okay, so this is your fx and also the fy. So maybe you could put it here first. Okay, you can put it here, okay, in your equation, in your formula, okay, before you replace it, because you need to find out what is the fx squared plus the fy squared plus 1 square root, right? Okay, so maybe you can do it this way. So it will be right, negative x, right, 4 minus x squared minus y squared and square root. Okay, the whole thing you square and plus negative y over 4 minus x squared minus y squared and square root, square and plus 1 and the big square root outside. Okay, so let's simplify this thing first before we replace it into double integral. So in the second question, you decide to use the polar coordinate, okay, which means that this thing you have to transform to polar coordinate as well. That means that you have to convert it to the r and also the theta. Okay, so this one you could write it as x squared plus y squared, and then you have the 4 minus x squared minus y squared square root, right, and plus 1, and then outside you will have a big square root. Okay, big square root. Okay, so you can convert it. Okay, you can convert it, so it will become r squared, so over 4 minus r squared. Okay, 4 minus r squared, right, and plus 1, okay, and plus 1, all right, yes, okay. Okay, so now we can put this thing inside our surface integral. So our surface area, it will be double integral. Oh, you have a z here, so the z you have to replace with this. Okay, the z is 4 minus okay, I convert it straight away to, okay, right, so multiply with the this one, r squared over, now you have a big square root. Am I right? Well, I think it would be easy if I combine this thing. Okay, how to combine it? Hold on, let me think about it. How to simplify it? 4 minus r squared and plus 1. So you get r dr d theta. Right. Okay. Never mind. Let's continue and see how. Okay. So this one you can combine. Alright. This thing you can multiply it inside this. Okay, inside this one. And the r is outside. Okay, the r is outside. So when you multiply it inside, it will be a big square root. R squared still remain. Okay, so this part, okay, will be cancelled out. You left 1. And you will have a 4 minus r squared. Okay, 4 minus r squared. So r is outside, dr d theta. Okay, so this thing when you multiply this one with this thing, okay, so the square root will be like missing because you multiply it inside. Okay, so it will be like just like square root 2 multiply with square root 2, it will be equals to 2 times 2. Okay, so let's try it. Correct. Right. Okay, so square root 2 multiply square root 2, you get 2. Or this one is 2, 2, 4. 4 square root, you get 2 as well. Okay, so this is the concept. This is the concept. Why this thing, you don't have the square root anymore. Right. Alright, so now we simplify it again. So this thing will be cancelled with this one. So you left 4. 4 square root, you get 2. So you have a 2r dr d theta. Okay, you need to define the interval. So interval will be from 0 to 2, 0 to 2 pi. Okay, so this thing you can press calculator. Okay, you can press calculator, integrate 2x. Right, you get 8 pi. Okay, you get 8 pi unit square. Alright, okay, so this is for the question 3b